Now we know the object have a knife circle. We can create the object, we can use the object, and we can delete the object if it's no use. Now we have example to show you how to do these steps in your code. Here's a geographic system. Now we have the plane coordinate system with axis and y-axis. Okay, and now inside the system we have geometric object. For example, we have a point. Yeah, a point we know that have x and y position. We get a point on this coordinate system, and we have another geometric object. It's a rectangle. Well, how to define a rectangle? Now let's see, we have a point. So the point is the up left point, the top left point, and we have the width and the height. And now we have a rectangle inside our system. So we have a point items, and we have a rectangle at items inside our geometric system, and we can do some operation on these items. For example, for the rectangle, we can move rectangle from here to there. And how to move it? Because we unremoved, so the width and height keep the same, will not be changed, and only change it is the top left point. Now from this position x2 y2 to a new position x3 y3. Okay, that is move operation. This is what we want to do to build a simple geometric system. Okay, so how to build the system? As we talked about before, we should think about it using object-oriented technology. That is the objects inside our system and the relationship between them. So we have this diagram. We describe it, use the UML. Now we have this three classes inside of this diagram. The create object demo is a system. Our geometric system will name it as create object demo. This is an object, and we have point, this geometric item, and a rectangle, another geometric item. And how about this relationship between them? The create object demo and the point, as we know, the point inside of the system, how it comes out? It must be created by the whole system. So the create object demo, the system, the geometric system, and the point between them should be the aggregation or composition relationship. Which one is suitable? The aggregation or composition? It must be the composition, because all of points are created by our system, by the create object demo. The create object demo is responsible for the whole life cycle of the point. So between them, the relationship is composition. So we use the rhombus, field rhombus, and the arrow to describe this relationship in UML. And one create object demo and lots of points. Okay, and the rectangle, another object items in our system, is the same. Between the create object system and the rectangle is the composition relationship, and one create object demo object and another rectangle. Okay, so it's use in. And between the rectangle and the point, which relationship is suitable? It must be aggregation, because as our definition, a rectangle, how to draw a rectangle, the top left point, and the width and the height. So a rectangle have a point, a top left point, but between the angle and the point, there's no responsibility for the life circle. So this is different from this create object demo and the point. The create object demo must be responsible for the life circle of the point, but the rectangle is not. And the point and rectangle between them, the relationship is aggregation. So we use this rhombus, the hollow rhombus, to describe this relationship between them and the one rectangle and the one point object. Okay, this is how to design the system. After we design the system, and we will write using Java program language to write the program, write code for it. Okay. Well, here is a code for the whole system. We have the create object demo. This is a class name. Inside class, we have main method. We have a lot of statements here, and the statement to use to create object and use this object. For example, we create a point, we create a rectangle, and we will access this object and get a value of the width and height, and we calculate the area. We move this rectangle from one place to another place. Well, lots of operation. Well, the code, the whole code, we will talking about in the future. After we finish learning how to create object, how to use object, and then we will come back. We'll come back to read this code. I will give more explanation for this code and make sure you understand everything. Okay. Now we come to the point. Okay. How to create a point? The point, as you know, is a very simple geometric item. Only the position is required, the x and y position. So this point, this class, if we want to create this class, we need the member variable as x and y, the position. So we have the x and y as member variable. We define it as type, any type. Suppose we use the int value as its position, the x and y, and we have a method. For this point, the method as construct as a point. Now we write the code for this class. Now the class point, the name of class, as you know, the block stands for class, and the first block is the name of class is point, the name of class point, and inside it we have this variable, we have the method. So this is the variable, the x and y. We define that x and y are all int value, and the plus sign stands for public, right? And get its initialized value as literal value as 0. Okay, both of them is 0. And its method, the method name is the same as this class name. This kind of method we call them constructor. The constructor used to initialize this whole object. So how to initialize it? We give its parameter x and y, and use the x, y, we assign the x to the member variable x, or assign the parameter y to the member variable y, and then we get the initialization for this object. And once we get this code for the point, for the class, how to create object inside the memory. Okay, now we use this statement. Let's write as point orange and score when, and we use the equal sign, a new point, and let's parenthesize into this 23 and 94. Okay, this statement, we use this statement, we create object in the memory, and we get a reference variable that we use to access the object. How does statements work? These statements have three parts for it. That is declaration, instantiation, and initialization. Okay, three parts for this whole statement. Well, the first, declaration. The declaration is the left part, the left side of this assign operator. The point, origin, and score 1. Well, this is declaration. And the point is a class name. And origin and score 1 is a name. It's a reference variable. We define a reference variable named as orange and score 1 and use the reference variable to access the object which is type is point in the future. So this is the first step to declaring a reference variable to access the object. Okay, but at this step, no object is created. We only declare a reference variable that can access the object, but now there's no object inside the memory. So we come to the next step. The next step, we call it the instantiation. Now we use new, the keyword, and use the keyword, and we create an object based on this code we write in Java programming language. And now we create an object inside the memory. And the first step, we have define a reference variable with limit as orange1, and this first step. And then the next step, we use new, this keyword. Once we use the keyword, we create object inside the memory. Now this is memory. And inside memory, we get this point object. Okay. This next step, this left due to new operator, we get object inside the memory. And the next step, once we get the object, the next step we will initialize this object. We use a parameter. Now we use a constructor. The point is a constructor name. Now the constructor is point, and we pass the parameter 23 and 94, the x and the y, to this constructor, and the user code of the class code to initialize the memory variable of x and y inside the object. Yeah. So now we use a constructor. We invoke the constructor. We will assign the value for the memory variables. Now the memory variable, we have x and the y, and now the x and the y, we have the value and 23 and 94. Once we execute, we invoke this point, this method, constructor method. Okay, and now we have object inside the memory, and inside the object, the memory variables get this value. Okay, now we should build connection between the reference variable and this object inside the memory. How to do it? We use the operator, assignment operator. We use assignment operator, the equal, build connection between them. Actually, this to execute this assign operation, we have this stress for the memory. For example, the stress for memory inside inside the memory for the object, the stress is 1, 2, 3, 4, 5, 6, 9, 8. It's a stress, And this step, we use this assignment operator. We will put this address into this reference variable. Well, 1, 2, 3, 4, 5, 6, 7, 8. Now we build connection between the reference variable and object inside the memory. Use address. Okay, but this step has performed automatically. You don't know the address. The only connection between this reference variable and object, but you don't know how to do it. It is done by the JVM, okay, not by you. Now this is how to create object inside the memory. Now we have a reference variable, and we use the reference variable in the future to access the object inside the memory. Okay. So this step is very important. After we execute the statement, we will have an object inside the memory. The type is point, and we have a reference variable as orange _1, and use it the variable we can access the object inside the memory. Now we look at the rectangle class. The rectangle class is the same. As of definition, the rectangle class have a point, up left point, and the width and the height. So we design the class. The member variables will have a point, the top left point for the rectangle, and the width and the height. Okay, and the method for the rectangle, we have a constructor. It's the same as a point. We should have a constructor to do the initialization work, and we have the move method to move the rectangle from one place to another inside our coordinate system, and we get area method to calculate the area for the rectangle. So the left side is a code. It's the same. The rectangle, the class name rectangle. Inside the class body, we define the variable width and height, the all energy value, and we have the left top point as a point, is an object. So the orange is a reference variable. So it describes the relationship between this point and the rectangle, the aggregation relationship between them. And here there is constructors, but we have 4 constructors: rectangle, and next page we have 3. The fourth, we have 4 rectangle, 4 constructors. What is different? The parameter. The first construct has no parameter. The second one have one parameter, and the 2 parameter and the 3 parameter. So they are different. They are all constructors. We call this overloading. That means we design more than one version for the constructors or the methods. We call it overloading. The point is, once we define the different version for this constructor, use different parameters, we can use this constructor I want by different parameters. And let's look at these constructors. Now we have a constructor with 3 parameters here: the point, the width, and height. And the constructor, we know it makes the initialization work. So the point is the left top point of the rectangle, and the width and height, and then the P and W and the H, and we assign it to origin and the width and height. This one is the member variable of the rectangle. So we get a parameter and assign to the member variable, and the finish the initialization work. Okay, and if we only 2 parameter, how to use it? Notice that with these, we use this and the parenthesis. This means we will use the rectangle, use this constructor. Means we use this constructor, the we have this counter with 3 parameters. So the 3 parameters, the first parameter, the second, the third. The first is up left point. Now the left point, we create a new point object at 0 and 0, x and 0, y and 0, and w and h. So we use the construct with 3 parameters to finish the initializing work. And if only one parameter, so we only make sure we get this left top point of the rectangle, but the width and height we use the default value as 0. Well, this constructor no parameters means we only make this left top point at the x, y at 0 and 0, and the width and height are both 0. Okay, there are 4 constructors. In the future, we will use one of them in our code. And besides this, we find another method named move. And the move means we move this rectangle from one place to another. So we have 2 parameters for the move. We just change the left top point of the rectangle from the current place to the destination place. So we use this parameter x and y and assign them to our left top point of the rectangle. Use orange x and orange y. We use this top left point and move the rectangle from here to there. Okay, and we define another method named the get area. With width times height, we get the area and return it. It's an integer value, so return it, get the area of this rectangle. That's how we define the code of the rectangle. And once we get the code, get the class code, that's the same step. We will create an object based on code. The same statement is here. How to create a rectangle? So we use, for example, now we create a rectangle with new. We create a rectangle object inside the memory, and then we use this constructor. This constructor is no argument. Well, the argument means this rectangle, the left top point is the 0 and the 0, and the width and height are both zeros. Okay, let's get a point. Actually, at this time, the rectangle is a point. And then we get the rectangle object, and we define a reference variable as rect. And use the rect, we can access the rectangle object we have created in the object, in the memory. Okay? And we used other version of the constructor with 2 parameters and with 3 parameters. That is, if you want to use a different version of the rectangle of the constructor, you use different parameters. No argument, you use this constructor. To this one, yeah. And if you have 2 parameters, for example, 50 and 100, and you match this constructor, you use this one with 2 parameters, w and h, and use wh, and you can make sure you get this rectangle. The left top point is 0, 0, but width and height, you get your value, and w and h. And if you want to use the constructor with 3 arguments, use this version 1, 2, 3, so you can put the point, the left top point of rectangle on the point you want as orange 1, and the width and the height the same. The left top point, the width and height. So different version of constructor, you can use it. This is how we use overloading. Inside the code, we define different version of the method. And once we want to use it, we use different arguments to choose one of them in our code. It's very important. And I want to mention that this step is only happened during the compiling process. When the code, the source code, is compared from the source code to the bytecode, during the step, during the process, the overloading will be performed. This is very important because in the future, we'll see another concept named as overriding. That is different from this overloading. Overriding happened at the wrong time period, but this overloading happened during the compiling time. Okay, that is different. Okay. Well, about the constructor, typically we should write a constructor for your code, for your object, for your class, but you can make it default. That means a class, if you do not write a constructor for the class, the platform will automatically to give you a constructor, but this constructor is no argument. So it cannot make the specified work, specified initialization work for you, but they have the constructor. They do have one, the default constructors. Okay. Now we get this rectangle. Now rectangle, we use new rectangle with 3 parameters. That means left top point is orange 1. Let's see, we have a point inside the memory. It's a point. It's here. It's a point orange, and the score 1 is a point. Inside it, x, y, and 23 and 94, and it's now the point is become this top left point of the rectangle. Now we have the width 100 and the height 200. Now we create a rectangle object inside the memory, and then we put address to the reference variable as rectangle 1. Now we have this variable access the rectangle object inside the memory. So inside the memory, we have 2 objects, a rectangle and a point. And the point is the left point of the rectangle. We use the rect1, this reference variable, to access the rectangle object. Okay. That is how this statement means. So it's very important. We should understand how this statement used and executed in the future. If you want to create object, you should use this statement to create your own object inside the memory.